Good morning, everyone. Welcome to today's webinar, Water Utilities in the Right-of-Way, Managing Critical Assets with GIS, part of ConnectMe's Asset Mapping Events, 2026 Smart Compliance in the Right-of-Way series. This session will cover how water utilities and public works can use GIS to track hydrants, valves, and pipelines within the right-of-way, streamlining inspections, reporting, and compliance across departments. I'm Tony Spicci, GISP, Executive Director of the GIS Certification Institute. Today I'll be moderating the event and hosting the Q&A later in the presentation. And I tell you what, we've got a great panel. But before we get started with the presentations, I'd like to run a quick poll of the audience. Each of you now should see that poll. And really what we hope to do is we just want to find out where you are and what industries and sectors you work with. The poll should have popped up on your screen. I can see it, so hopefully you can see it too. So please take a moment to fill out that poll and hit submit. And once we have everybody's answers, we'll go ahead and go over those real quickly. So today's event is designed to be very interactive. Please enter your questions in the Q&A space that's located on the bottom navigation bar of your screen. There's no need to raise your hand. We're going to just post the question in the Q&A section. And then when we get to that, we'll go over those questions and we'll allow the presenters a chance to respond to all of those questions at the end of the presentation in a panel discussion. So we're going to do the presentations and then we'll do that panel discussion at the end. Also, please be sure to participate in any audience polls that pop up as we go through the seminar. For information about our speakers and the event agenda, please click on the Resources tab at the bottom of your screen. We've also shared some useful links in the Resources section, which you can use and you can click on anytime during the presentation. Please note that this session is being recorded and will be available as download on demand after the event. You will receive an email notifying you when the recording is available. We'd like to thank our webinar series sponsors, Bad Elf, for making this educational opportunity available to you today. So today's featured speakers include myself, but we also have Dr. Nick Smilovsky, PhD GISP. He's the Geospatial Solutions Director for Bad Elf. We have Nick Clawson, owner and founder of SiteTwin. Gini Connolly, VP and GIS Director at Halff. And then finally, Julie Brown, the GIS Manager for Huntsville Utilities. Let's take a look at those poll results before we get started. Okay, so looks like we have a good representation of folks here today. Most of our folks come from local government, which is what we expect, but we also have a lot of folks for state government, industry, and federal government academia. So really good spread out, good diversity of folks. Most of our folks are coming to us from the United States and a few from Canada and Africa, so welcome to all of you. And then when we look at our business sectors, land and public administration, a fair representation, transportation. As you might imagine, public works and utilities has most of our folks, but that's what we would expect in this situation. And then we have a fair number of folks that fall into that other category. Folks that are participating are spread out across municipalities of different size. So we've got about half of the folks in large metropolitan area of over 100,000, but the rest of you come from smaller areas. So I think we really have a good diversity of folks in our audience. And we're really excited about that. So without further ado, let's get started so we have as much time for Q&A at the end. And I'd like to turn it over to Ginny Connolly from Halff. She's our first speaker. Take it away, Ginny.
I'm excited to be here with you guys today to talk about the importance of spatial data and managing everything water. We use, let me get situated a little bit. We use it for everything water, wastewater, stormwater to manage those assets, those critical assets. So my name is Ginny Connolly. I'm the GIS Director at Halff. I've been here about 5 years. I started out, I have a master's degree in city planning. I've primarily done GIS, been a GIS manager through my career, 20 years in local government. supporting utilities. I ended as a development director, so a lot of planning and development experience, but most of my experience is managing specifically water and wastewater utilities. So a lot of experience with software implementations, permitting, work order, asset management, emergency response on the private side and in the public side. So understand all facets of that, as well as asset management when it comes to really managing the utilities. So Halff, we've got 32 offices in the southern United States, over 1,400 employees. We are employee owned. So we started out in Texas, and we have a fair amount of offices in Texas, Florida, Arkansas, really where there's a lot of growth going on, we're around. Our practices, we are an engineering consulting firm, infrastructure consulting firm, also known as. And our practices the services we provide are grouped into three major areas: mobility, places of community, and then water and the environment. And so this presentation today that we're going to be talking about all things water. And we're a known water consulting company for sure. So what I wanted to talk about is really how GIS is behind every service that we provide when we talk about utilities. I've been in the industry a long time, over 25 years now, and we've seen it evolve into, work order tracking, reporting, workforce support, developing those CIPs, everything that we're doing. GIS is part of in the beginning, in the documentation, telling the story. What I want to talk to you guys today about, sort of set the stage for the next presentations. I always appreciate when I see somebody's perspective in their particular role at their agency. So I want to share what we're seeing, some of the trends that we're seeing the last couple of years where spatial data is being used to help manage and support these utilities. On the public side, I saw, of course, the work order and the O&M side. But from the private sector in the last couple of years, we have a broader geographic perspective, and we're supporting water, wastewater, stormwater, and reclaimed water as well. So one of the biggest things that we do as a consulting firm is master planning, that hydraulic modeling that comes with the master planning and providing capacity. So solving those growth challenges. And then second, which probably everybody's familiar with, is the different evolving reporting requirements. And then we want to talk about definitely the visualization. The visualization to tell those stories and gain that public trust has become more important than ever. And we're also seeing, I really wanted to cap it and underscore that we're seeing that these asset inventories for these critical assets are a requirement for all the different funding sources that have become available in the changing funding world. So I'm going to walk you through a couple case studies of each of these to just sort of give you a taste of different projects that we're seeing and how GIS and spatial data is supporting these. This is the town of Northlake, which is a suburb of Fort Worth, Texas, just north of the Texas Motor Speedway. We provide their engineering services as well as their GIS services for this growing town. There's a lot of area to be developed, and it is being developed right here. We call it the Golden Triangle in the Dallas-Fort Worth area. On the left is a map from their master plan. And we're shifting the thought from these static master plans to more of the dynamic master planning. So really getting that data on a more routine, frequent basis to make these master plans more livable and rather just than a three-ring binder that sits on a shelf. So on the right, there's you can see the two different water sources, the wholesale suppliers that provide water to the town. The growth in the town is outpaced what the comprehensive plan suggested, what the master plan suggested. So we track the development for the town, what stage the development's in, but we needed to also add, I'm just showing you as an example, we really needed to see how many connections specifically were going to be impacting that particular pressure zone to make sure there was the capacity in that area. So now with the development, we're tracking the connections, which has become important to understand. It's a little bit of a gap from what the work order and the permitting is showing, that we're really trying to manage those resources better. As soon as the meter is installed, it's integrated with Cartograph as well as the GIS. So the development department, the city manager's office, everybody can see when those connections come online, as well as, the SCADA environment. In this particular case study, I also wanted to show we forget that GIS really is behind all kinds of collaboration, but we're seeing, and I wanted to share, we're seeing the need for a lot, especially on the water and wastewater side and the stormwater side. A lot of these limited funding and limited resources, natural resources on the water, wastewater, as well as funding resources. We're seeing these are not localized issues that need to be solved. They're regional issues. So this was the town of Northlake worked with the city of Fort Worth through their master planning process to create a second redundant water line, the water supply. When you have, it's a little bit of it is a threat if you just have one water supply and it doesn't necessarily have the capacity. So a lot of these challenges are being resolved between cities and counties and districts with this GIS data. And it's able to be modeled quicker, updated quicker, and understanding what the adjacent infrastructure is necessary to ensure the supply for that particular area. On the reporting requirements, I think a lot of people we've talked a lot about through the years, past couple of years, lead service line, MS4 reporting, and I'll show a little about that. This is the state of Florida. And if you don't live in the state of Florida, they are really progressive on their water quality reporting, and they control the water quality, the different types of water quality by the different types of basins. And there's basin management action plans for those basins within Florida. They call them BMAPs. And each BMAP is unique to the particular areas and challenges in that particular basin. And so we're working with the city of Tavares in the middle of the state, Lake County, for developing on the Ocklawaha Basin, the BMAP. They needed to have a plan to mitigate their existing septic tanks and to have a plan to bring those into the wastewater system. And so they needed to know exactly where their septic tanks were. They did not have an inventory of these septic tanks, the people that were on septic tanks. However, they had a very robust GIS with tracking all of the sanitary sewer services and the water services. We were able to correlate that with all of the billing data, their building footprints. There's a very big, GIS desktop analysis to develop their septic tank inventory for the city. On the left, you'll see, which is in yellow, and then to plan what needed to be brought onto the system in the future years as part of their septic tank remediation plan. And so that's over on the right, showing these areas that can be phased and have cost estimates to bring those subdivisions, those areas, onto the wastewater system to really improve the water quality for the city. So I thought that was interesting, especially if you're not living in Florida and familiar with how they report. And GIS is at the center of all of it. I wanted to throw this in there because we probably have a good deal of audience that are GIS users. We are working mapping the storm drain inventory, helping the city of Arlington, and we developed some attribute rules to increase the accuracy and make the data editing more efficient. And on the left is just a snippet of some of these attribute rules. And so, of course, this improves all of their stormwater reporting. So if you are not, I wanted to put a plug in here. If you're not using attribute rules to manage these utilities yet, you're missing out, and definitely look into that because it really helps editing and it helps the quality of the data. One thing that we take for granted is visualizing data, but we have the data available now, this spatial data, to tell the story. And we're in a political climate, especially since 2020, a more volatile political climate where we need to engage the public and develop that public trust as utility owners, or supporting the utility, and get the stakeholders engaged as well. So we need to show them what that data looks like and tell the stories. And we're seeing this as a really important function of GIS that needs to be promoted and identified. On the left here, you'll see it's a story map. It was ARPA funding. This is one of my favorite story maps that we've provided, showing that it's not interactive here, but we had drone footage and showing where these particular investments were planned to be. The story map can be linked off of the city's website. So we're seeing this for comprehensive plans, master plans, all of those B maps. We didn't do the story maps for those B maps, but in Florida, there's a really cool, if you want to go look, a story map for all of those B maps. On the right is a project we're working with the city of Fort Worth on a corridor development concept. And so we're able to visualize this now fairly easily. We're designing it in 3D space, so we need to visualize it in 3D space to show all of the different people that are involved with this project, what it looks like, what the utilities look like, where the right of way is going to be. So that's very, very helpful. We are definitely a water resources firm. We're known as a resources firm. We do a lot of stormwater mapping, floodplain mapping. This is a visualization of flyover for Pinellas County that they use, and they've won lots of, they won one last week, a stormwater management at the national conference. They win awards, but it's visualizing the effects and the impacts of particular flood events and showing the community what it looks like. And so for those of us that are in the industry, we see it, we're aware of it, but you really need to engage different audiences that may not be as familiar. And so we're seeing these like 3D representations and visualizations increasingly important to tell the story of what that looks like, what flooding could look like in that area. And then it helps you identify what your vulnerabilities are, your critical assets, what needs to be mitigated, create those vulnerability plans from there too, vulnerability assessments. Lastly, I definitely wanted to talk about funding. As the funding mechanisms have changed in we've seen the last couple of years for almost all the agencies between federal and state, and it's a very dynamic environment for funding. And a lot of this money is coming through federal state agencies to help support the utilities, especially on the drinking and clean water fronts. And it's through requiring or getting priority funding. It's a requirement of some of these funding mechanisms to have your asset inventories and your critical assets mapped and understood and be performing asset management activities to get some of these state revolving funds, all the drinking water funds. So that's the big money that a lot of water utilities, so many water utilities really depend on, as well as getting the FEMA money for the risk assessment. You need to have a hazard mitigation plan, understand where your critical assets are. We're seeing if agencies don't have them already, then these agencies, like if local government or utilities don't have them already, there's a lot of programs to provide those asset inventories and asset management plans so that then the agency can better manage their assets. So I wanted to leave that plug if you guys are something you're thinking about getting funding or needing funding. Um, the importance of your asset inventory, your critical asset inventory, whether you want to enhance it or start it. And if we have a great funding team, we can help find that funding depending on where you are. Lastly, just sort of summarizing the trends that we're seeing from the consulting side on the water management and the critical assets, growth challenges, limited resources and solving these serving these growing populations, evolving reporting requirements where the federal and state agencies are asking for a lot more information than they used to because that information can be tracked, and then developing that public trust with your communities and your stakeholders. And then lastly, there is funding for it, and you can get additional funding if you have it. So funding, it's an important part of managing these critical assets is understanding the funding sources that require it and that can provide for it. So with that, I'm going to sort of set the stage and I'm going to hand it over to Dr. Nick from Bad Elf. And I think a lot of people are familiar with Nick. Um, so I'm going to
Awesome.
hand it
Well,
up.
yeah, thanks, Ginny. That was awesome. Let's see if I can break everything. Hopefully my screen is good to go. Um, Yeah, that was great. Thank you so much, Ginny. And just thank you, everybody, for coming today as a sponsor of the event. It means a lot to us that people are participating and wanting to learn more about GIS and this industry. Also wanted to say thank you for Tony for doing the MC of the event. Bad Elf is a GISCI supporting organization, and so always great to see Tony. So what is Bad Elf going to be talking about today? What are we going to be talking about? I'm going to be talking about RTK corrections. I'm going to be talking about high accuracy data collection and making the data collection, the data that you need to acquire so that you can populate systems like Ginny was just talking about. We're going to talk about how easy Bad Elf is making it for the masses. So why don't we go ahead and just jump right in? Because we're going to be talking about industries, let's go ahead and run our solutions poll. You should go see a poll on your screen now. So just take a few minutes. It'll be up and you can answer it, just looking to see if you're interested in any help or learning more about any of these critical technologies. So I want to leave you a few more things to think about. Ginny really set this entire educational webinar up pretty well. But here are a few more kind of added points I'd like to kind of put on top of what Ginny and Tony started us with. There is roughly about $175 billion spent per year on public water utilities across the United States, according to the U.S. Environmental Protection Agency. That's about and these are estimates to our best ability, but between planning, engineering, asset inventory, and geographic information systems, that accounts for about $6 billion. The AEC, construction, rehabilitation, replacement of equipment, you're talking about $54 billion, and about $115 billion in operations and maintenance. The point here is that a lot of money is being spent in the water industry every year. The EPA also estimates about $625 billion in drinking water infrastructure needs over the next 20 years. So there is a lot of improvement that needs to happen in the next 2 decades. Of which 422, almost $423 billion is EPA's 2-year drinking water needs for distribution and transmission pipelines and infrastructure. So what's that saying here is the EPA is really saying that distribution, transmission of the water and the water infrastructure behind that is going to be exceptionally critical, for maintaining healthy populations. EPA estimates about 4 million lead service lines still remain nationally, and I'm sure everybody here understands why that's problematic. We don't, need to think back to Flint, Michigan. And a couple more thoughts. There are currently about 329,000 workers and professionals in the public water utilities space. In the private sector, there are roughly about 233,000 active workers and professionals. So in total, there's about 500,000 people in the United States that work in the water utilities industry, particularly in the right of way and for public interest. That's a lot of people. And my big push for this presentation today is going to be all of those people that are doing these jobs are potential data collectors. Everybody now who does work in this industry can go out and collect really, really good data. So how do we do that? So we'll go ahead and show the results of the solutions industry poll before I answer how do we do that. All right, looks like we got about 72% right now are currently using GIS to manage critical assets, so that's awesome. I'm also a fan that no one said not sure, so we're at least all in the right webinar, so that's good. Are we interested in using GIS to manage critical assets? And let's see here, about 20% said yes, about 25 say maybe, and almost 50% saying already implementing, so that's great. Are you interested in learning about geospatial technologies? Looks like there's some interest out there. And then also high accuracy GPS or GNSS. Is it being utilized to collect these assets? And interestingly, it's pretty split right down the middle, right? So apparently there's still a lot of people out there that are not using, maybe more digital modern means for data collection, but that's totally okay. That's why we're here. So if you're like, who in the heck is this Bad Elf company? No, we don't sell skateboards. We've been around for about 17 years now. And we are what I call a low-cost alternative GNSS or Global Navigation Satellite Systems provider. So we create GPS that you can hook up to your phone, as you'll see, and then fire up an app, say like Esri Field Maps, and go collect data in the field. We are kind of specialized in the fact that we work with iOS and Android and Windows apps, and we've got offices kind of across the United States. I'm actually in the San Antonio office, but you can see our kind of distribution there. We are a small business. Our equipment's assembled in the USA. I mentioned we are a GISCI endorsing company, so if you don't have your GISP, you should start aspiring to get that done now. We're an Esri Gold partner with a bunch of badges, but and also on GSA if you're looking for federal purchasing. So what is a global navigation satellite system then? If you didn't know, it's just a fancy term to say all them satellites in the sky. So it's every bird in the sky. It's the Russians, it's the United States, it's the Europeans, it's the Chinese, and they're all working together to provide a position to a device on the ground. RTK, or real-time kinematics, the RTK part in my title, this is a process of which a base station or a terrestrial continually operating station or a movable station is collecting data and then broadcasting a correction to a rover device, a device in your hand, like your cell phone. Back in the day, this used to be an extremely complicated process. This used to be really expensive. You used to have to look at PDOP calculators, and you'd have to kind of predict and forecast where satellites were. Those days are over. There's so many satellites in space now, and RTK systems are so prolific. Everybody now can get RTK. RTK is the way your Uber drives itself. It's the way Uber drops food off at your apartment in Austin, or it's the way Waymo or Tesla AI drives the car without you. RTK is not just used in surveying and mobile GIS, but it's utilized in all types of mobile devices, like even say an automated lawnmower. A few weeks ago, I was at a Top Golf, and the guy that was driving around collecting the golf balls, the attendant, he drove off, and then a robot came out, and a robot was actually driving around collecting the balls. So, using GNSS and RTK to have a high accuracy of position, so where that robot is, right? So Bad Elf, we create these devices that provide position. We provide accurate, affordable, and versatile solutions. We create our devices with the field user in mind, whether you're on the public side and working for the government, state and local, or feds, or you're on the consulting side like Halff Engineering or SiteTwin. Nick, you'll hear from in a little bit. We integrate into real-time GIS workflows. Our idea here is to make your life as easy as possible. Again, you don't need 4 years degrees in geodesy anymore. You just need a Bad Elf device that works really easily. What this enables is consistent spatial positioning. So you have confidence when you go out there, your accuracy and your precision will be repeatable across your teams and geographies. A lot of people have, large areas in which they need to work in. And all of this leads to better informed decision-making, probably the reason you're here today. So quickly, we have two main products at Bad Elf. We have our survey grade receiver called the Flex. And if you're interested, you can always contact Bad Elf later about this, but it's a fully survey grade, engineering grade device. You can connect it with peripheral devices like laser rangefinders and radios and utility locators, barcode scanners, you name it. However you want to catch all those Pokemon, collect all those data, we can do that for you. More recently, we've come out with the Bad Elf Flex Mini. This is a much smaller device that's near survey grade, about 2 centimeters when you connect it to RTK. This device is, it's going to attach right to your cell phone, kind of making a three-handed job a one-handed job. We've got scanning handles, but the idea here is you can see the scale that this device provides centimeter level accuracy to some, with being in the size of your hand. We're no longer talking about multiple setups and multiple tripods and big batteries and hiking up wires and all this crazy stuff. Nowadays, you can just get RTK and high accuracy for fractions of a dollar. Recently in May, Bad Elf released what we call the spring app release, and we released new features called instant accuracy. And this is really what we're going to be talking about today for Bad Elf, and we're going to round this presentation out. Instant accuracy is an idea that we had. We want everybody, all those 500,000 workers in the industry of water utilities, all of those people are potential data collectors. You don't need to use no GIS. You don't need to do land surveying. But if you have a cell phone when you join the organization, you can get Esri field maps or a plethora of other apps installed on your phone. And for next to nothing, you can have a Bad Elf RTK device that connects. And not only does it connect, it does it all automatically. You don't have to do anything. We had a user one time say, no more clicking. They don't want any more clicking. We made it so easy. And you'll see here in just a moment that all you have to do is turn the device on. So let's watch this quick video. Okay, fun little video commercial there showing exactly the process of using instant accuracy. So the idea is your field worker, they turn the device on, literally just power it on. That device is automatically going to Bluetooth connect to your phone or tablet of choice, Android or iOS. Once it's connected, the Bad Elf Flex fires up in the background and auto connects the RTK. You've done nothing. Your screen can be totally turned off on your phone. Within a minute or so, you're going to automatically be receiving the RTK corrections. You're in the centimeter level accuracy, and all that field worker has to do, let's say if they're on an iOS device, is start using any app. As an MFI certified device, we work with Apple automatically, or you could fire up, say, something like an Esri Field Maps or Quick Capture or Survey 123 and skip the entire setup. If your field worker can turn on a device, they can go collect data for you. Okay, so RTK, real-time kinematics. Bad Elf partners right now with three options, but we work with any public network. So whether it's GeoNet, Point One Navigation, or SwiftNav, they are all built into our app. And when you purchase a Bad Elf device, you actually get 6 months of free RTK as part of it. The idea here is we want everybody collecting RTK data. Why not? Like, it's addictive. There's never going to be less water infrastructure in the ground. Time to go collect, right? And so this is my house. If you've ever seen me present, maybe you've seen this picture before, but this is an RTK base station installed on the back of my house for a super low cost. Again, autonomous vehicles of the future will not drive themselves without RTK. And so there is a big dash right now, say like with GeoNet, to get as many stations set up around the world as possible. They have about 22 to 23,000 stations for a cost of like about $200 a year. And with a device that's the size of your hand, now you're talking centimeters. Why is this important? Risk reduction is one reason, right? High accuracy data allows for fewer conflicts, better early decisions, reduced rework, clearer communication between the disciplines. As accuracy goes up, risk goes down. The context prevents the mistakes. Like we can work with scanning apps like Pix4D, for an example, and you can then have the trench open, scan, and collect all the underground data of that utility, that water main, fill it all back in, and then have that in the GIS, and you use it down the road for augmented reality. This is all based around something we call BYOD, or the bring your own device approach. Again, you have a cell phone or tablet that your organization gives out, you hook up your Bad Elf device, and you go and start collecting data. It's really that easy, okay? And then nowadays, all those data go into really sweet dashboards for live analytics, for better to inform decision making. And this is no longer pie in the sky stuff. So for the 50% of the attendees today that are not currently using GNSS, This is no longer your dad's GPS that you had to, cut your left pinky finger off for. They were talking, this is a device that's about the same cost as your iPhone in your pocket. So what are the key takeaways? And I'm done. There's a lot of work to be done in the water utilities industry. Duh, right? Whew, that's a hard takeaway, right? There's over 500,000 people directly working in the industry. So this is not a small segment of people, right? There's a lot of people there. With instant accuracy in Bad Elf, everyone can go collect high accuracy data. The bridge has been gapped, or the gap has been bridged. Like we no longer have a excuse to not have the data in the database. That means that's a lot of data, and that means that's a lot of data collectors. High accuracy field data is no longer expensive, and RTK networks are plentiful. We live in the golden era of GIS, or what I like to call the geospatial moment. So that is what I have for you today. Here are some citations, just so you know I'm not making things up. I really appreciate it. Just remember, you turn it on, you get RTK, and you get to go collect high accuracy data for your GIS. So coming up next, I'm going to go ahead and stop sharing my screen. I am super excited to introduce Julie Brown. Julie Brown is the GIS manager for Huntsville Utilities. Julie's got a really, really compelling story. She absolutely loves printing maps. Maybe she'll tell you all about it. But Julie, if you can, would you come on up to stage?
All right. Good afternoon or good morning, depending on where you're at. I'm Julie Brown from Huntsville Utilities and located in northern Alabama. I hope everybody's doing well. We're dealing with some rain today that's going to create some humidity going into this weekend. So it's one of those things that we're getting used to. Just a little bit about myself. I've been with Huntsville Utilities for 17 years. I will give this preference. I am not a formally trained GIS person. I originally started my career as a CAD operator. I have a background in doing drafting and design work. I started, like I mentioned, I started with Huntsville Utilities 17 years ago in their mapping department. At the time, I had no idea what GIS was. And there was an opportunity to start working. So I said, let's take it. Since then, I now understand exactly what it all is. I continued my education and went and got a degree in management of technology. So I'm not an engineer. I'm not a GIS person by official things, but I live and breathe it every day. So let's see. Just a little bit about Huntsville Utilities. We are now the largest city in the state of Alabama. We have surpassed the Birmingham area to reach that. Huntsville Utilities is a municipality. We serve gas, water, and electric to roughly over 200,000 customers. We have mainly serve in Madison County. Our water system does go into Limestone County, which you'll see on the next slide. We have about 900 employees now. 17 years ago when I started, we had about 600. So we've definitely seen the growth. One thing about Huntsville, you may have heard, we are the Rocket City. Where you go through town and you'll see rocket stuff all over the place. NASA Marshall Space Flight Center is located in our area as well. So just a little bit about our water system. We are the oldest public water system west of the Appalachian Mountains. Originally, it was started by a big little spring that is actually right outside of our offices in the downtown Huntsville area. Just a couple of facts about us. You can see that we have 3 water treatment plants, 1 groundwater plant that is also a treatment plant. We have over 1,500 miles of mains, and then we also serve roughly 109,000 customers. You'll notice here on the map, this blue shaded area is our water service area. Out the white on the northern part of that is going to be Madison County, And in that little middle there, as I talked about, the space side of it, that is Redstone Arsenal. We do not provide them service. They have their own water treatment plant, but we do officially help operate their equipment out there. So a little background about our GIS and our mapping system here at Huntsville Utilities. My former boss, he just retired in October with 40 years. He started this mapping department in 1985. Originally, that mapping was done on all paper. In the early 90s, they started digitizing everything. I've heard stories about it and all that good stuff that they digitized and put it into MicroStation. That we actually just stopped using MicroStation for some of our work in August of this past year. After that, we went to a Oracle Spatial database using Hexagon's G technology. That is where we just came from. In August, we implemented NISC's solution. I'm not sure if anybody's familiar with that, but NISC is intended to help utilities and co-ops do their billing, their mapping, their inventory, and all of those things. We've been very happy with our switch. One of the things that NISC pushed us to do, and this may be surprising to all the GIS folks on this call, up until August, we at Huntsville Utilities was not, or were not, a Esri shop, and now we are officially an Esri shop, and I can officially say I'm excited about it. Esri has the tools that are made to map, and that is one of the things that we have really been missing prior to this conversion. We're able to push out maps a lot faster now than we were prior. So Dr. Nick, he was the one that actually asked me to step in and talk. We started using Bad Elf. We went through a time period where we were trying to figure out what we were going to do with GPSs. We went through and we evaluated the R2s and the DA2s and also a stereo product. During that time, we determined that the Bad Elf was the best solution for us. I will say this, I've been a Bad Elf fan for probably 7 years now. I had originally heard about them from another software that I had used called Global Mapper. I love that software, and they had a tie-in, and I was like, one day I'm going to buy that, and officially have. I love the name. I'll put that out there. I do love the name, and I laughed when Dr. Nick mentioned the skateboard company. It definitely does look like a skateboard company logo. So not a GPS. Had a lot of questions when we went in and made those purchases. The reason we did go with the Bad Elf is we do not have to have a subscription. And now I understand that they have their Bad Elf does have their subscription services. But in the state of Alabama, we are able to access the Alabama's CORS stations, and they are giving us, with these Bad Elf mini extremes, it is giving us survey grade accuracy. We are very fortunate in the state of Alabama. I've talked with a couple of folks from AlDOT who is over that. I'm like, let's just keep that going, make sure that we're able to keep using that stations for free. So we didn't have to purchase any subscription. We just had to purchase the unit ourselves. We have actually purchased 35 of these units. The picture up in the left, we have 35 of them. We have deployed about 15 of those. We're doing a slow rollout of those. At this time, we are putting them in the hands of our inspectors in our water and our gas areas. So one of the issues and one of the things that I have heard at Huntsville Utilities since I finally started understanding what GIS was is we want everything GPS, and we want this done, and especially with our water operations folks, they want to be able to drive straight to that GPS, or I'm sorry, that valve. We want all our valves GPS. We want to be able to access that at quick and easy, and I don't want to ever have to use any other tool other than my iPad and the little GPS. Well, with that being said, when I offered it to them, I said, okay, here's your units. Here's how you can help us update the map. They looked at me like I was completely crazy. So I have a graphic here of Mario. I mentioned to several folks, one of the guys in our operations, they said, I just want to be able to find it. And I said, it's not going to jump up like Mario and say, here I am, here I am. You're still going to have to get that probing rod out, especially when things get covered up. I have a picture of Thor here. If you'll notice the gentleman on the right, he looks a lot like Thor. He has been huge implementation for this. He has a GIS background himself. He has took this opportunity to say, okay, we're going to get these maps correct. So our operations folks are kind of finally starting to buy in that, okay, if Jake or Thor says it's going to work, it's going to work. And there's been many of time that he has spent out there showing them how accuracy is and how to find it. They've pulled tricks on us. They've buried old valve lids to see if we could find it. So we've truly been tested, and we finally are getting them to buy in. Now, let me go ahead and say this. So what we're currently GPSing we're GPSing our valves, our meter boxes, and valves, meter boxes, and hydrants. Let me switch this screen. And that is on all newly developed areas. You'll notice, as Jen was talking earlier about using attribution, if you'll notice that highlighted section down there, that is what we used to get. They called that the water operations folks called that the two-way measurement. So there, basically that means that valve is located 4 feet off of an edge of a curb. As Huntsville continues to grow, that curve changes. So we have officially said, okay, we'll still continue to get that location, but we're also going to get that on a GPS. And you'll notice on this map, we also have all of our water meters. They're represented by a W or an S for a sprinkler and a water meter. We have all of those. That is where we have a water service. Originally, going back in time, we put all of those services in the middle of the house. We didn't know where those services were going to be. We placed those just in a generic area that we know that it feeds this house somewhere. So after the GPSing, we're actually going in and grabbing those locations. It's a little closer. I've hit a wall recently. Our operations folks are like, I don't really know that I care what the meter box is. And I said, well, the deal is when we do an AMI, we are in the process of deploying an AMI system for our water. Those lids are going to get covered up. So we're going to go ahead and GPS those, and you will at least be able to have them. You'll notice on here that we have an attribution for GPS. That was one of the ways that helped us determine if it was a good location or not. Scroll down. So as I mentioned, we're really getting our guys to buy into the GIS side of it and trust in the map. One of the things that I will tell any individual, whether it's electric, water, or gas, if the map is wrong, please let us know. We're invested in getting it corrected. I have a gentleman who also works with Jake a good bit. I thought he is really invested in getting this map corrected. And so for just next steps for our process. So the next steps we're going to start using the GPS is we need to do valve inspections. We do those on a 5-year basis, is my understanding, with our operations folks. I have asked them while they're there doing that valve inspection, take that 30 seconds or even less than that and grab us a GPS coordinate. We also want to start updating our maps where those locations are not exactly in the right spot. We're wanting to clean up those maps and make them where those are cleaned up. Nick mentioned all those fancy dashboards. That's something that I'm wanting to get going. We have a lot of, I'm sure as anybody knows, on the local government side, you have a lot of reporting that you have to do. I'm wanting to be able to let our upper management know what actually the data looks like. And like I said, one of the things that we're really happy about is with the Bad Elf is that it's simple. Nick really talked a lot about this. Also, going back to the different ones that we looked at, the Bad Elf was the only one that had a small screen on it that can actually give you real-time feedback of your connection. It has that information. It'll show on there the accuracy. So instead of having to look at the iPad, which you can do also, you can look at this at the Bad Elf at the accuracy of it. But what they've told me is they just look straight up at it and see what accuracy they are at. I'm not going to throw around the accuracy that they're getting, but they are getting inches. They will tell me that they're getting under inches, but I'm going to say inches. And that is because of that correction that we are doing. Nick also mentioned the old school GPSing equipment that they had to do, where you had to bring it back in. When I discovered that this technology was finally here, I knew it was time to start deploying those within Huntsville Utilities. So I appreciate the time and the listening and all of that good stuff. And I'm going to pass it over to the other Nick.
All right. Good morning, good afternoon, everybody. Wanted to say thank you to Tony for the great kickoff and Connect Me for having all of us and everyone in attendance. I'm the owner-operator of SiteTwin Utility Mapping and Locating. We're based in Austin, Houston, and Dallas. Been around for over 2 years now. And my role here is to help bridge the gap between both the field work and the technology that we've been discussing today. A lot of our presentation focuses on the underground, given GIS pertains to all data collection, above and underground. But in the theme of the presentation and theme of the event today, we're focusing on a lot of challenges and a lot of solutions as to how to better map and document our water infrastructure in the cities, which is especially from our side, the most requested utility and, of course, the hardest to find. So there's the title, Managing Water Infrastructure in the Right of Way, and a lot of it's about how field teams can bridge the gaps through utility visibility, coordination, and construction readiness. Why is it so hard to manage water? Well, From the field and just general trends, we see a lot of things. Obviously there's population growth and infill projects as communities become developed. Road expansion is something that frustrates everyone that drives. A prominent user of I-35, I can speak to that honestly. Aging mains and legacy repairs, some of our infrastructure dates even more than 50 years. So that is obviously a problem, especially from a documentation perspective. Emergency repairs competing with planned work. When outages happen, when strikes happen, when there's leaks, someone needs to get there now. And there's CapEx improvement projects that are always years out. But today is really what we're dealing with. A lot of our push, a lot of our work has been around fiber and telecom conflicts in the right of way. I'm sure you've seen and heard stories, and there's just a lot of infrastructure, and it's really a product of a lot of spending going on from the federal and local governments around the country. A lot of congested corridors, there's really no removing these things. It's just more people, more utilities, and you have a limited time frame to service everybody. And most importantly, what we find is the staffing shortages across public works, and then in the data collection realm and the underground utility mapping realm. There's a massive demand for it, and a lot of the technology, as you've seen today, is available. It's just getting the right people to use it. Given how easy it's become, it's still a matter of, it's a human-based problem. It's a lot of staffing shortages that we've seen. So it seems, especially from the conversation, cities are being asked to do more and more with buried systems, and they can't fully see it. Not a lot of transparency back to the office or to the city and the citizen. So some of the challenges we see, this is the most common. Water utilities are installed without tracer wire. If you're not familiar with tracer wire, it's just a metal wire end to end that electromagnetic locators can put a charge through, so to speak, and locate them. That's traditional locating. A lot are either broken or just not there. Another tool that we employ and we push for everyone to use as a part of the investigative process is ground penetrating radar. As the people that have used it or been a service recipient of it, soil conditions are extremely limited, which limits your visibility, especially without tracer wire, which is a step before that GPR scan. No existing records. That is a common theme. Whether it's a small municipality or a larger one, not just not having them, but not having the right point of contact or the right communication channel in order to get those, and then get those in a usable format, something that your field team can adopt easily. You can send to the phone, and we can get to work. And that brings to the next point about breakdown in communication, which again, as cliche as it might be, is the biggest challenge that we see from the field to the office. And then data silos. Maybe it is available, but it's not available to everyone. It might be locked in the backroom closet, as we've all heard before. And that a lot of those problems lead to things like unknown line locations and unknown offsets, depth uncertainty across corridors, abandoned lines and inactive assets often don't get updated. There's active generations of construction that goes on, and then offset valves and fittings from prior work, if not documented correctly, are kind of lost in the ether or lack thereof. So why specifically is water? On top of the tracer wire, a lot of the water lines that we see are non-conductive materials. So PVC and HDPE are often installed without those tracer wires, and you can't go hook up to something that isn't metallic or doesn't have a connection end to end. Deep installations under pavement have limited surface access for direct connection, and the deeper the utility, the harder and less reliable the GPR signal can be. Weak signal returns from aging joints, mechanical couplings, and cast iron inhibit consistent EM signals. So beyond just it being metallic, there's certain tools, there's certain ways to go locate that are, easier and more reliable than others. Of course, there's incomplete records and crowded corridors and the limitations with ground radar that we were talking about. But again, water lines are often the most requested and the least visible assets underground. Something that we see and that I'm sure some of people here are familiar with is the demand for locating these underground facilities is far outpacing the capacity. So the 811 ticket or the call before you dig, whatever it is in your state, that is really being pushed right now. There's a lot of infrastructure going on. There's a lot of growth, especially with the data center push and just natural population growth that really leads to some staffing and then demand and supply capacities from our side. There's long backlogs, right? Municipalities have projects that are, years in advance or years behind. Limited crews, both in-house and then a limited availability or resource to get a third party is really not helping keep up with the demand. If you've ever been on the contractor side, you've probably made a call before and no one showed up, or you waited past your 48-hour time. Time is money, again, the cliche, but especially when you have multiple projects and you're trying to service all available, that really leads to a larger problem within the construction economy. Capital work queued behind daily emergencies, right? I mean, great to have plans. Today is really what we're dealing with, and the only day that we're given. So it really is the most important part, especially when there's outages and emergencies. Um, and reactive dispatching drives overtime. So again, having the right people in place, having the availability, it really becomes a constraint. So our goal is to plan beyond one ticket at a time workflows through accurate data collection, and leveraging a lot of the tools that were mentioned, whether it's a GPS such as Bad Elf, GIS platforms that have real-time feedback loops that you can view from the office to the field, and then EM locators now that can actually connect to these GIS tools via Bluetooth, and you can capture data as you go. Like they're saying, if you have someone that can open a phone, you have people that can collect data. So, I mean, some obvious notes here, but what happens when visibility is poor? Water main strikes. You've probably seen a video or something online about water spewing 10, 20 feet in the air. It is not Schlitterbahn. It is often the product of somebody digging, without accurate information, maybe even with a mismark, right? And it's no dock on the available records or the 811 providers. Their job is to go mark where the utilities are and where it says on the map. That's often different than where they actually are underground, and it leads to a lot of strikes. Of course, there's outages. Again, back to road delays, which is the most frustrating for all of us day to day. And then claims and change orders. A lot of project disputes leading to budget overruns and a lot of rework. If it isn't documented, I mean, emphasis on rework. It's rather redundant. Emergency overtime and personnel, and then of course public frustration, which peeks its head up just about everywhere. So what's the shift from reactive to proactive management? We've talked about a lot of problems, but every opportunity you go in the field is an opportunity to capture valuable data. One way we do that is by positive field locates and verified marks. If you're able to hook up, if you're able to verify where an underground utility is running, you're able to collect the data. That's a great opportunity to take your GPS out and make sure you get it back to the GIS team or whoever it is that needs these records, preferably on a real-time feedback loop. But it's easy enough to, go to your phone and export a file for any of us, especially open potholes and exposed utilities for the engineers and well, really surveyors and engineers of the world. Uh, you got a pothole to get to your quality level A if you're going to be able to collect that data. Exposing utilities, opening up potholes is a premier time to be able to collect that data, and sometimes it's just missed. Capital improvement replacements is definitely something you can help plan with previous accurate records. Also, another opportunity to go collect more information, new subdivisions that we drive by all the time in service taps. Instead of just running the lines there, let's go ahead and collect the information, and be able to distribute it back to the city, whether that's on the private or public property side. And then valve and hydrant maintenance visits. I think Julie touched on this very well. Every time you go out, it's an opportunity to collect the valves. If there is some type of leak, if there's some type of damage, being able to stake out or walk back with high accuracy GNSS receivers to valves and hydrants makes a massive difference, both on the public side and then, of course, for internal operations. Phrase that we go by is the best time to map infrastructures when it is visible. So, as built is a term we're all familiar with. As is a coined term I've seen used in the industry quite a few times. As is conditions do rely on a GIS system and your ability to collect that information, and you can get very granular. A lot of these GIS platforms have the ability not just to collect coordinates and even put photos in them, which is a great step. You can do all kinds of metadata and any type of features and variables that you need included. So the GIS team has more information to work with. That post-processing time, even if the information is collected, can lead to a massive backlog on the GIS side and then ultimately getting it back to the field. So collecting things like pipe alignment and depth, material and diameter, valve locations and IDs, your hydrants, your meters, your services, documenting whether it's abandoned, and then taking your photos, your field notes, and following the current ASC 38 method. It's a really good opportunity to be able to do that. So, in sum, finding things underground often starts with field locating, whether that's above ground markers, electromagnetic verification, or ground penetrating radar returns and readings. When you do find the utility, when you're able to document something is in an accurate location, hook up your RTK system, find your GNSS, capture it out. It's again on a phone or a tablet. All of these applications have a mobile version. There's really no excuse that you shouldn't be doing that in real time, which then gets pushed, whether to the GIS or the engineering office for verification on active projects, and then QA/QC, which is the constant feedback loop, which makes it even more important that there's a real-time portal or some type of access back to current and updated information. Outputs that would be more favorable or I guess more usable. While PDFs are ultimately what a lot of people rely on and do want, extremely useful, a KMZ overlay, a shapefile, geotagged photos are a standard for our company and a standard for a lot of the people in our shoes, which allows both engineering, GIS, public works, and third parties to work together. Excuse me. It's a little more about, what we had discussed before, but this is what I would interpret more as a investigative process. When going to locate, you could probably put historical records review at the top, direct field observations right after, which, it really does matter the experience of the person doing it because there's a lot you can tell above ground about what might be underground. And unless you have a trained eye, unless you have the experience to do so, that can really get lost. Then you move to your electromagnetic locating where available. You pull out your GPR to help verify exactly what you had located or scanned. And then pothole verification is the cream of the crop, so to speak, as far as being able to put your eyes on the utility, collect the data. What that results in is again GIS ready data, PDF utility exhibits and conflict callouts, KMZ overlays, your asset updates for whatever nomenclature or feature sets that you carry within your internal operations, and then more importantly, cap planning intelligence and CapEx intelligence for future use and future development. Some examples of where cities will use this model before paving and mill overlay programs, road widening corridor improvements, water main replacements and extensions, conflict zones and crossings, which is a lot of where we get called in as a utility locating and mapping company, unknown service investigations, trying to find something abandoned, trying to find the source of the leak, growth corridors, and new subdivisions that are popping up every single day, and recurring leak and pressure problem zones, which I think we had touched on previously in this presentation. So reality, and this is just a visual for what we've been talking about, but a city has to respond to multiple emergency breaks annually, and multiple is probably say hundreds, in the same aging corridor. Crews operate reactively, facing unknown line locations and unknown offset valves every time that they dig to go following the problem. The shift includes, instead of repeating blind responses, they begin capturing every repair excavation in the GIS, verifying alignments, valves, depths, materials, photos, notes, as much information as you can collect. It's available to do so in the palm of your hand. 12 months is a rough timeline. Again, a lot of what I've talked about is a quote unquote real-time feedback loop. But when you're talking about things like cities and collecting whole water infrastructures, it can still be a lengthy process. So, ultimate goal is to have faster dispatching with reliable valve shutoffs, better contractor coordination, staging, improved replacement priority planning, and reduced uncertainty for crews. So why municipal teams are pushing to work with a lot of parties like that, or just pulling in third parties for support on this side, fast responses, right? I mean, you've probably made a call for a variety of services where you won't hear back for weeks. I think it's hugely important that the private side steps up and has an incentive to be able to say, hey, I'm going to pick up and be the first one available with this solution, which sounds really simple, but often is not. Scalable support. So, I mean, the city has plans, but plans change, and often they're outpacing the people that are there. Being able to work with teams that have availability to do so, and the tools and technology to do so is a huge push. Unified coordination. There's obviously some setup on the front end when creating data dictionaries and feature sets for GIS systems as they can change. But once you get that established, the unified coordination from field to office can be seamless. And then a clear QA, QC, right? Being able to have documentation of a who, what, when, where, and why of everything that's happened, everything that's there is a huge benefit for cities, ultimately leading to, again, ready GIS data and a huge risk reduction both for the people in the city, but the guys in the field, right? I mean, it can be a dangerous job. We're talking water here, but there's many more utilities underground that can lead to a lot more catastrophic responses. And that's us. So I appreciate you guys. Nick Clawson, I'm the owner of SiteTwin Utility Mapping, and thank you guys for the opportunity and everyone here listening today.
Okay, so I'd like to take a moment and thank all of our speakers for their excellent presentations. So we're going to move to Q&A. So right now we have 3 questions in the chat or in the Q&A section. If you have any more, please go to that Q&A section and add your questions. Let's get started with the first question. Alex asks, can you give examples of helpful attribute rules to use in utility GIS? And Alex asked this during Ginny's presentation, so I'll let her go ahead and start with the answers.
Thanks, Tony. Absolutely. Some of our favorite attribute rules are the ones that they'll do a spatial analysis as you're typing one attribute or putting an attribute in. It'll select maybe like the pressure zone or city council or work order zone. So things you don't need to manually enter anymore. It's just doing it from a spatial representation. It could be a floodplain or something like that. Getting information from a different layer, adding it to that layer, um, showing the X and Y's are already calculated. We have a lot of GPS people on the call, but a lot of times we'll have clients that want to see the X and Y like actually in the attribute table. And so an attribute rule is a great way to just show the X and Y of when you're entering information in that attribute table. And then the validation is really helpful for topology. We use that a lot between the topology between the pipes, maybe a service line, making sure service or like a flow direction always on a pipe is always connecting. And you can really use Arcade and script it pretty complexly to make sure that it's making sense intuitively, it's making sense topologically. So very, very helpful in utilities. And part of that was really the foundation of utility network. But if you don't necessarily need or want to go to full utility network, attribute rules provide a lot of streamlined validation too.
Great. Anybody else want to chime in on that one?
Maybe just at a broader view, but if excuse me, if you are using the ESRI or Esri, ecosystem and ArcGIS online, using field maps, I do recommend nowadays you can use Field Maps Designer. If that's not something you're using yet, Field Map Designers kind of make that first step into the foray of like things like attribute rules. Something we see our customers using today. Geofencing is a kind of a neat thing for right of way. But you can really set up all kinds of stuff in that Field Maps Designer piece. Certainly worth your time to check out.
Great. Thanks, Nick. So James asks, with the large amount of water consumption for AI/hyperscale data centers, would the existing infrastructure be able to support future demands for new data centers and future growth for municipalities? Julie, let's start with you and we can go from there.
Yeah, sure. So here in the Huntsville area, we do have a few data centers. Obviously, we get a lot of requests through our Chamber of Commerce that says, hey, this company wants to come here. Do they have the availability? One of the things that we do here is make sure that we have a master plan. We try to pinpoint those areas that are open land so that we know that, hey, this may be a new data center or something like that. I will say that we don't have a lot of requests for data centers at this time, but I will say we have a lot of manufacturing that needs a lot of water, and they have started looking at those. Our planning group, we have a whole separate department that works with engineering, such as Jen, Jen there, and gets all that information. Yeah, so it's big, making sure you're planning for it. That's big for us. I'll let Jen speak a little bit on that.
Yeah, I mean, I don't know if we can speak for every geographic area on the water source. Like Julie says, there's different. I've seen parts of the country and areas that we work with, and they may not have the capacity, so they're not getting approved because there's not the capacity. Maybe the developer doesn't want to pay for that capacity. And then I've seen a lot recently that are getting a lot of publicity politically, but it's a 1 or 2 inch meter. It's pretty small, but it's called a data center. So there's a big range of things that are going on and sort of taking off in the news. But I don't know if I can answer completely. Like, do we have enough water overall for this? I think it's sort of a region, a local by local
Yeah.
and region by region issue.
Yeah, that is it's definitely it's also has to do with, what businesses want to come here. As I mentioned in my thing, Huntsville is a huge growing area. So that has caused a lot of things, and that is a concern for us is do we have enough water? Luckily we have a planning and an engineering department that does that.
Anybody else want to chime in? All right, next question is from Marcus, and actually he asked it while I believe Nick with a C was presenting, but I'm sure Nick without a C will probably want to chime in as well. And the question is Bad Elf using GeoNet RTK connection services?
Well,
Yeah. Go ahead, Nick.
we do with our bad elf. I could say that. I think one of the better benefits of it is that it is agnostic to your correction system, and there was a very great deal that we got with the RTK subscription along with the bad elf. So I can answer yes, we do. I think Nick will be able to add a lot more context on the availability and use cases for it.
Yeah, thanks, Nick. We are a partner with GeoNet. We have 3 official partnerships that you can find their RTK service, the optionality in our app. That would be GeoNet, Point One Navigation, and SwiftNav. But what I would just say, even beyond Bad Elf, no matter what color GNSS you have or GPS out there, there are state networks. Always check your state first, just like Julie said. If you're part of the government, there's a good chance you're going to get it for free. Like here in Texas, you work for the government, you can get into TxDOT's RTK system. We point a lot of people there. There are also third-party systems out there, like a SmartNet or a TopNet that Bad Elf devices would work on. I would just recommend for anybody looking to use RTK, just do it a little due diligence. A lot of these systems will have what they call coverage maps, and it's sort of like where you are, your project is, and how much coverage they have there. And some will do better. There's a Midwest RTK called DigiFarm. So if you're in Indiana, it's a really good option. So lots of options out there. But yes, GeoNet is one of them.
Great, thank you. So these two came in after the panel, so I'm going to open it up to any of our speakers. Antarius wants to know, how are utilities handling the gap between having asset data in GIS and actually getting that information into the hands of field crews when they're standing on site trying to locate and work on an asset?
Yeah, so that was one of the conversations that I'll take that, I should say. That was one of the things that I kind of wished I had talked a little bit more about. So we have, I don't know if you can see them, we have iPad Pros that are actually deployed to nearly all of our operations folks. That was part of our NISC implementation. Everyone has access to what NISC calls their Compass map, which is an Esri-based map that they have access to. That has always been one of the issues here, is getting that information to the field once they have it. With NISC, we have been able to push that data out. It's visible to everyone. Everybody in the company has access to, if they're not in the field, they have access to it on a web browser as well. If they, and one of the things that we have issues with is how to get that information back. We're really encouraging them to take screenshots, submit something like a help desk ticket, that we actually track that. And we've also done as simple as, hey, send me an email. I've mentioned many a times, if it's flooded up in the back of your truck, it's no good. But if you bring it and put it on my desk, I'm going to get it taken care of. I hope that answers that question.
Yeah, I'd like to add on to it too, Julie. My experience when I was a GIS manager, it was always more about the process and the management and not necessarily the tech tools that you have, but making it accessible and making everybody understand that they've all got ownership in it. Everybody's got a piece of ownership in that. And then you can, of course, use the tools better and the technology better, but it's not necessarily one person's responsibility versus others, but getting those processes, whether they're as-built, redlining processes, your field collection processes, just getting them down so everybody's aware of what you need to collect and how accurate you want it to be.
Absolutely. Yeah, I mentioned in the buy-in. If you get one good employee to buy into that, that is in the field, and they start to see how useful it is. One of the things that I tell, in utilities company, people come here and they generally stay here. One of the things I've said, they're like, this is slowing me down. I'm like, you're not helping yourself. You're helping that person 10 years from now.
Yeah.
And that's what we're still working on, getting that in.
Yeah.
Anybody else want to chime in? Okay, maybe our last question, unless any more pop into the Q&A. Eric asks, does Bad Elf offer real-time connections if you don't have access to the internet in the field?
Yes, we do. So like many of the GNSS out there, we have a couple ways we can work around LTE or cell phone connectivity. So the traditional way is through what we call base and rover. And so you set up one GPS or GNSS on a tripod. It broadcasts the RTK correction via UHF radio to your second device or rover. This is a standard practice in GPS field data collection for the last 30 years. So that's the kind of tried and tested way you can use anywhere in the world. The second way is we have satellite-based corrections. So instead of getting a terrestrial-based RTK correction, imagine that the satellite overhead is shooting down multiple radio signals. And in fact, usually about 2 to 3 signals or bands, L1, L2, L5. That L5 band can actually have an RTK correction in it. And so what it is like you connect to those satellites and it provides a correction. So in Europe, for an example, they have the Galileo constellation of satellites, and they're very proud of something they call HOS. And so high accuracy something system. And no matter where you are in the world, you can connect to this and get corrections. The third way that is kind of the new fun way, and we're talking AI. So if I didn't say Elon Musk, I couldn't ruffle somebody's feathers. But Starlink, so satellite-based phones are really taking off, pun intended. And so we have a lot of organizations, especially in some of the energy sectors that may be out, say, in the West Texas area and the Permian Basin, working on a midstream pipeline. They've got the Starlink setups on their trucks that then broadcast Wi-Fi, and then even newer than that, and again, you got to test this out on your own. You can get a virtual SIM card on your cell phone now. So like my Verizon phone can have a secondary virtual SIM card from T-Mobile, and T-Mobile has a satellite Starlink account. And effectively, the Starlink satellites have Wi-Fi small sat cell towers on it. And so long story short, base and rover, satellite-based corrections, or nowadays, you could try out a new fancy Starlink or sat phone type. It's a long-winded answer, but no longer is that becoming as big of an issue. Like we're getting to the point where you can turn on your phone and it works a lot of places.
Awesome. Thank you, Nick. Anybody else want to chime in on that one? Okay, great. So I'd like to take a moment to thank our speakers, Ginny, Julie, Nick, and Nick, for presenting today and taking time out of the schedule. So let's go ahead and give them a, virtual round of applause. And thanks to all of you for joining us in this latest installment of the 2026 Smart Compliance in the Right-of-Way series. Keep an eye out for upcoming seminars. They will be advertised as they are available and scheduled. And you're going to be receiving an email soon letting you know when the recording is available. So, again, thanks for joining us and have a great day, everyone, and take care.